Hi everyone. Today I'm going to show you how to use the LDR module or photoresistor module. And just to focus in on, there's really only two parts that we're going to look at it for the moment. On the left side, this component here, this part that's kind of standing up, this is your photoresistor. This is a resistor whose resistance changes depending on how much light is being shined on it. And so our microbit will be able to detect changes in the amount of light that you shine on this little piece here. So we are going to use our microbit to detect these changes. Let's talk about how we're going to connect the two now. So to connect the two, you've got these 4 pins here. The top one says VCC, the next one says GND, the next one says DO, and then the last one says AO. We're going to use the top two, VCC and GND, and the bottom one, AO. So let's go ahead and connect these to the microbit. We're going to flip the microbit over just so we can see at the bottom, these are the ports that we're going to connect to. All right, so we're going to take a wire, and the wires I have, it's an alligator clip on one end, and then the other end of the wire has what we call kind of like a female part, and that's going to slide directly onto the pin. So my first wire I'm going to use to connect the GND pin on the module to the GND port on the microbit. Next, I'm going to use another wire to connect VCC to 3 volts. And then lastly, I'm going to use my third wire to connect the bottom pin that says A0. I'm going to connect this to port 0. And so this is what you want yours to look like. Then you can take your USB cable and connect your microbit to your computer. Once it's connected, if you flip it over, you should notice that there's a small LED that illuminates. And you should notice these 2 LEDs that illuminate on the module. Now let's go on to the code. Once your system is now connected to the computer, you're going to need some code in order to transform this into a Theremin. But before we do, we want to look at the readings that we're getting from the photoresistor, from this module. So we want to look at the readings that are coming from this. And so this basic code we can use just to look at the readings. Just going line by line super quick. In lines 2 and 3, we're creating variables. Line 2 creates a variable called sensor pin, and it just represents the pin to which the sensor is connected. And in this case, we've connected our module to pin 0. The second variable is just going to hold the values that are being reported by the sensor. In the setup function, we're just creating a blank canvas for us to print things to. In line 12, we just set the background of this canvas to white. And then in line 15, this is where we're actually telling the microbit to go to the sensor pin, which is pin 0, and read it. And whatever value it gets, store that in sensor value. And then in line 19, we print up that value. You'll see in a moment, so if I run the code, you're going to see here it says sensor value, and then it prints what's stored in the variable sensor value. And so right now, the sensor is producing a value of 149, about 150. Now watch what happens to this value as I move my hand over and lower and lower and lower towards the photoresistor. So as I cover the photoresistor and I'm getting closer to it and closer to it and closer to it, notice how the reading goes up. And if I remove my hand, if I move it away, it goes back down again. And so what you want to do with this simple code is you just want to make note of what's the minimum value you're getting and what's the maximum value you're getting. So right now the minimum value I'm getting is around 150. And then the maximum value I'm getting, if I just do like a very simple cover, the maximum value I'm getting is around 650. Okay, so ranges from about 150 to 650 for my module. For your module, it might be slightly different. It also depends on your current light conditions. Okay, now the next code we're going to look at is the actual Theremin code. And I already have the Theremin code saved to my desktop, so I'm just going to upload that. You are welcome to type it directly from what you see here. And so this code is a little bit more complicated, so we'll go line by line before we run it. So the first set of lines is just creating variables again. You're going to notice these two identical to what we had before, but now I'm going to make note of what was my minimum sensor value and what was my maximum. My minimum was 150 and my maximum was roughly 650. And so you can enter your minimums and maximums here, and it doesn't have to be exact. Then for Theremin, to produce a sound, we have to tell the computer, or the microbit, our computer, we have to tell it what frequencies we want in terms of the sounds produced, because frequency determines the pitch of the note produced. So to do this, we have to tell the microbit to create an oscillator, and that oscillator is going to be driven at a certain frequency. And then you get to set the range of frequencies that you want your system to operate within. So I'm going to say my minimum is going to be 261. I think that corresponds to like a C3, I believe. And the maximum 1047, I think that corresponds to a C5. You can look up these values if you just Google musical notes, frequencies, table. You can Google and you can see what frequencies different notes correspond to. And what I'm eventually going to do is I'm going to map these sensor values to this range of frequencies so that a 150 sensor reading results in a 261 hertz frequency signal, where a 650 sensor reading corresponds to a 1047 hertz signal. Okay, then under setup, we create the canvas, and then this time we have to create the oscillator. So we are creating a P5 oscillator. It's going to operate like a sine wave. And then we get that object started. Okay. Then down here, let's get in the draw function. We draw the white background. We get the reading from the sensor. We print that to the screen, to the canvas. But then we need to determine the frequency from that sensor value. And we use the map function to do it. So with the map function, you give it 5 arguments. The first argument is just sensor value, whatever value is coming from the sensor. Then you tell it what is the minimum and maximum of that these readings are going to range between. And we identified that at the top. The minimum value is 150, the maximum is 650. So you put the minimum and the maximum that this value is going to range between. Then you give the frequency minimum and the frequency maximum, which in this case we said was 216 and 1047. And then the map function figures out, using proportions, maps whatever this reading is, the sensor value, maps that to a frequency in this range and stores that in the variable f. And then we're going to print that to the canvas. The frequency being played, we're going to print what that frequency is, and we're going to print it with no decimal places. Then we are going to tell the oscillator to oscillate at a frequency of f. And so that way we're going to hear that note, whatever that frequency is, we're going to hear that note. And then lastly, we have this function called draw frequency bar. This is going to visually represent what the frequency is as a bar. You're going to see that below first, and then down here, and then I'll explain how it works. So let's run the code. And so right now, you can probably hear very low notes. Notice you can see the readings, and you can see the frequency being played. And if I scroll down a little bit, this is where my bar is going to pop up that's going to tell us what frequency it's oscillating at. So as I move my hand closer, notice how the bar starts to grow. And notice how the frequency is increasing also as the note is increasing. Okay, how's this happening? I'm just going to re-upload this code. I'm going to refresh and re-upload this code so that it's not actually playing. Okay, so now let's just look at how the bar is being drawn. We identified, so this function, draw a frequency bar, what it does, it takes the minimum and the maximum frequencies and divides them by two, adds them, divides by them by 2 to get the average. And we store that in the variable f mid, meaning like the mid frequency. And then I tell the computer just to print these values, minimum, mid, and maximum, to the screen. And you saw the minimum, the mid, and the maximum on the left side of the bar. You'll see that again in a minute. Then down here we use the map function again to take the current frequency and map it from the between. We know it's between the minimum and maximum frequency values, and map that to a number between 0 and 200. And whatever that number is, store that in L. And that's going to control the length of the rectangle. Now you notice the color of the rectangle also changed as the frequency went above or below the mid frequency or the maximum frequency. So here I've just got a small conditional. It says if the frequency is bigger than the minimum but less than the mid frequency, make the rectangle blue. If it's bigger than the mid frequency but less than the maximum frequency, make it green. And if it's bigger than the maximum frequency, or if it's smaller than the minimum frequency, make it red. And then draw the rectangle. And so now if I run this code one more time, notice you can see the minimum, the maximum, and the mid frequency. Notice that right now the rectangle is blue. And as I cover it and it goes over the mid, it becomes green. And as it goes even higher, it becomes red. And there you have it. You have your own theremin. Thanks for watching.